Okay, so today there's actually going to be two parts to this. I'm going to talk about what a pilot owner can do on a certified aircraft. FAA lists specifically there are a number of activities that you can do. And then I'm going to talk specifically about borescoping cylinders and how that can save you a lot of money in maintenance and reduce the chance of a significant problem with the engine. I think everybody knows me here, so I don't have to tell you anything about myself. So let's just start off with the regs. So the regulations that give you the authority to do preventative maintenance on your aircraft are outlined in 14 CFR Part 43. And it also talks about, if you're a mechanic, what you can do, and gives you that authority. But down, if you come all the way down to the bottom here, it says, except for holders of a sport pilot certificate, I'll talk a little bit about that, a holder of a pilot certificate, so you've got to have a pilot certificate to do this, issued under Part 61, which is who certifies private pilots, may perform preventative maintenance, so that's really important. They're calling this preventative maintenance on any aircraft owned, so you have to not only be a pilot, but you have to own that aircraft that you're working on, or operated by that pilot which is not used under Part 121, 129, 135. These are all commercial operations. So if you're a pilot and you own the airplane, but you rent it out or you use it as part of a flying club, you can't do the preventive maintenance on it because it's a commercial operation. You'll have to get an A&P to do that. Okay, so I've got 3 slides like this. These are all the things you can do. But I thought rather than reading through them, I would just talk about the majority of them. And first, start off saying, does anybody know what you can do as a pilot owner of an aircraft in terms of preventative maintenance, the kinds of things you can do? Anybody want to venture?
Grease wheel bearings.
You can grease wheel bearings, that's right. Yep.
In general, anything that does not alter the airworthy structure of the aircraft. That's a good summary.
That's a good summary, but you got to be a little careful about that. For example,
change side windows.
Yeah, that's right.
But not windshields.
But not windshields, but side windows, which is what you're doing right now.
So the guide I picked out of this was, if there's anything that is part of the aerodynamics, wings, surfaces, things like that, you can't touch it.
Right. If you think about the really important elements of an aircraft, the structure, the controls, the electronics, the panel, the electrical system, they don't want a guy that hasn't had the training to work on those kinds of things. And Skip's, that broad category Skip gave is pretty good, but there are some exceptions. For example, you can actually repaint your aircraft. It gives you the ability to do external finish repairs on aircraft. You can repaint a cowl, you can repaint fairings, you can repaint the fuselage. Guess what they don't want you to repaint?
Control surface.
Controls.
Actually, it's a balanced control surface.
That's exactly right. It's, aircraft that have balance weights in them, because if you paint those, you may change the balance. And the only way you can make an adjustment to that is to remove the control surface, balance it, and see where, and then add the appropriate amount of weight to counterbalance or remove it. So, so you got to be careful with that kind of stuff.
George, what if you have your plane painted professionally? Do they do it?
Yes.
And they disassemble a lot.
Yes, they do.
Do they do the rebalancing of that?
Yes, they do. They have to. And that's part of the requirement.
What about changing the oils, spark plugs, fan belt, tires?
Yeah, so they don't say fan belts, probably because it's tied to the alternator, right, and that's part of the electrical system. But you can, right, you can service, you can change oil, you can pull spark plugs and put them back in, which is gonna make it possible for you to actually borescope the engine, right? If you couldn't pull spark plugs, you'd have to have a mechanic.
Light bulbs?
Yeah, right, so you can do light bulbs, you can replace light bulbs, and they give you the capability to actually touch the electrical system and look for failures in the lighting system. So you can look at that part of it. So if you've got if you replace a landing light and it doesn't come on, there's a problem with the wires or the switch, they'll let you look at that. You can work on that.
What about interiors?
They give you pretty much free run on interiors. In fact, they'll actually, a lot of aircraft, the seats start cracking and breaking on older aircraft. They'll actually let you, you can remove any of the interior as long as it doesn't get into the structure or the control system. It doesn't impact that. You don't have to do something, remove a structural component or something. You can remove the interior and replace it. You can repair seats. You can yourself. You can, rivet on a doubler or get a part welded or weld a part up yourself if you need to. You can do the upholstery. So, yeah.
This goes a little along with this, you're not allowed to replace seat belts because those are structural safety things.
Actually,
However, they've made an exception with shoulder harnesses because the FAA recognizes shoulder harnesses are such really neat things to have. Pretty much if you follow their guidelines and put in something reasonable, they'll accept it, even though technically an A&P is supposed to do that because it deals with the structure of the airplane. Did I get that right? Cross-check me.
not quite.
Okay.
They now actually allow you to replace your seatbelts.
They actually did.
Yeah, it's in here. I can probably find it in a minute or two.
There's one caveat to all of this, is if you're under a supervised, from an A&P or IA, then you can do just about anything you want.
But in that
Yeah,
case,
yes.
If you're under supervision.
Right. For the things we're talking about, you don't have to be supervised.
Correct.
What Roger's saying is, for the other things, you can do it if you can get an A&P to supervise you. And that's how a lot of people do their annuals.
And that's how I modified the trapeze.
Yeah.
So I've been confounded by the fact that my Cherokee 64 has only seat belts, doesn't have a shoulder harness.
Right,
When I look at the price of the kits, they're not that much expensive.
right.
But when I, asked for an estimate from someone to do it, it's ridiculous. If I was to get an A&P to supervise me, could I do that installation?
Yes, if you can if you can get a mechanic. This, like shoulder harnesses, like Skip's talking about, the FAA is really trying to encourage people to put those in because it's proven that they are a huge improvement in safety in a crash, and particularly in the front seats. And, but the loads on those shoulder harnesses can be a ton in a crash. You can have over 2,000 pounds of load on a shoulder harness, just your upper body in a crash, a survivable crash. So oftentimes they need to tie into a structural component. And that's why they don't let you just do it on your own, because you're going to be tying. You're going to probably have to drill a hole, attach a bracket to the skin or a rib or a bulkhead or something.
when I did the Comanche shoulder harnesses, it was the same sort of thing. And I had a shop do it because you actually have to go in and rivet in doublers and stuff into the monocoque structure of the fuselage in order to do the attach points for the shoulder harnesses. And that, you could do it depending on how good you are with aluminum work, but that was the level at which I figured, look, I want somebody who knows what they're doing. On the other hand, I designed my own for the Taylorcraft and put them in myself, and
It's just one point of curiosity.
Yeah, yeah.
Pull rivets or solid rivets?
solid.
So let's touch on some of the other stuff. You can do lubrication. You can lubricate components. You can service gear struts, you know, the shock absorbing gear struts, you can service those. You can't disassemble and rebuild them, but you can service them. If you have elastic shock absorbers, like
A Tailorcraft?
like a Tailorcraft on older aircraft, you can actually replace those yourself. You don't need a mechanic to do that. You can replace the landing gear tires. I'm going to talk a little bit more about that. And you're not required to be supervised by a mechanic to do that, which always amazes me. You can do fabric patch repairs. You can do rib stitching. They talk about what you can do with
No,
balloons.
you can't do rib stitching.
I'm sorry, thank you, Skip. You can make simple fabric repairs not requiring rib stitching.
Yeah.
Thank you. You're going to keep me honest too. You can put hydraulic fluid in the hydraulic reservoir. We talked about decorative coatings, interiors. You can paint, you know, if you need to say clean up some corrosion. You can apply paint to prevent it from corroding in the future. Upholstery, let's see, fairings, non-structural cowling, small patches. You can do all that. The side windows, which Walt's doing. Replacing safety belts. Replacing seat parts, broken circuits on landing light. Oh, now, I guess I'm going to be specific. Landing light circuits, so they don't want you going into the wings and replacing your navigation lights, your nav lights, or troubleshooting. You can replace the bulbs, but you can't work on the wiring. Let's see. Oh, you can take wheels and skis on and off. You can actually replace any cowl. So you have a damaged cowl, bottom cowl or a top cowl. You can replace that yourself as long as you don't have to remove the propeller. They don't want you to have to pull that prop off.
We can know when we go out and do the borescoping on the Tailorcraft, you'll see I've taken the cowl off, but the nose hole is still there because I'd have to pull the prop to do that, and that's not something I can do.
You can clean plugs and you can gap plugs, as well as taking them out. You can replace any hose connection except hydraulic connections. They don't want you working on hydraulic connections. And I suspect the reason there is the high pressure. They're high pressure connections. And you can get in trouble if you don't torque them properly. You can replace prefabricated fuel lines. So if you buy a set of new fuel lines to put in, you can replace them. They don't want you fabricating your own fuel lines. A mechanic can show you how to do that. We've actually showed people how to do that in the past for amateur built folks, but they don't want you to do that. But if you buy a prefabricated line, you can replace it. You can replace your fuel and oil strainers and filter elements. How many of you, this is probably going to apply to everybody, how many of you actually take a look at your fuel elements when you and clean them or replace them when you're
Fuel elements?
your fuel filters?
Oh, okay.
In your aircraft. So Roger Ray, Skip Graves, John does, George does. So you guys are pretty much all amateur aircraft builders, so you know exactly what they look like and where they are. But like if you have a carbureted aircraft, there's a little fuel filter in the carburetor. It's pretty easy. It's safety wire, but you're allowed, by the way, to remove and replace safety wire. So you've got the safety wire. You can take that out. It's very easy to get to and fix. The same goes for a fuel injected engine. Those types of things are pretty easy to replace. You can replace or service the battery. Let's see, I think we're getting into generalities here. Oh, you can replace magnetic chip detectors. So if you have, for example, a magnetic chip detector at the bottom of your your oil sump, you could take that out and replace it. I think that's pretty much it. And I've got, I'll pass these out, it's front and back, but it lists all of those items. If you're interested, you're welcome to take one there. Okay, so we've talked about what you can do. Now let's talk about how do you do it according to the FAA. There's really 4 things here that you need to do. First is you need to have the requisite knowledge to do it. If you've never changed a tire on an aircraft before, you don't have the requisite knowledge to change the tire on the aircraft. There's real subtleties to aircraft. So you really want to, jacking the aircraft. Let's see, what do they call a Cessna on jacks? Skyjack. You guys ever seen how tall the jacks have to be to jack a Cessna high wing up? So you have to have the requisite knowledge, which means you have to have done it before or had a mechanic instruct you in it before. You need to have a document, and this is true of all mechanics too, you need to have a document either generated by the manufacturer, which could be a manufacturer's a maintenance manual for your airplane, or it could be a service bulletin, a service instruction. It could even be a document generated by the FAA, like 4313B, which we use all the time as amateur builders. You need to have a document that tells you how to do it. You can do it, if you have the requisite knowledge and if you have a document, and that has to be available to you. It could be in electronic form or it could be in a bookshelf, but you have to have that so you can refer to it. And that's why you see mechanics a lot of times will have these huge bookshelves full of maintenance manuals for specific aircraft because they have to have that. You need to have the appropriate tools to do it. So if you're going to change spark plugs, you need a torque wrench. You've got to have a torque wrench to do that. And it should be calibrated. And you can calibrate it yourself if it's one of these old beam type torque wrenches, that have the pointer on them. That gets calibrated by making sure the pointer is pointing on 0. And if it's not, you can tweak it a little bit to get it to point on 0.
That constitutes calibration?
Yeah. That's sufficiently calibrated, yeah.
That's
So
why I
whereas
like
if you
my
have
one.
if you have a clicker type, then it's a little more complicated, right, to make sure that it's generating the right torque.
Will, can you do that calibration yourself, have the bolt on the wall and put the weight on the handle and make sure it clicks at the right, can you do that yourself, or
Well, that's
do
a
you
really
need
good
a
question.
shop,
I
do you
don't-
need an approved shop?
You
to
need,
calibrate?
actually, you need a piece of paper that says that this has been calibrated in the last year. So, I guess you could generate that.
I wonder-
I don't know the answer to that, actually.
Or you take one in to get it covered.
Mark?
I went to Harbor Freight with one of their torque wrenches, asking about it, and they said, just buy a new one, or we'll give you a new one.
Every year? There you go.
But I'm not sure I'd recommend using a
Harbor
Harbor
Freight,
Freight
yeah.
torque wrench on an aircraft anyway.
Yeah.
Interesting.
So,
If we had a Chinese aircraft.
so I've got 2 beam type, so if you ever need one, I've got one for light torques and one for heavy torques, so if you ever need one, you're welcome to borrow mine.
And I've got an electronic one, it's a little box, and it's got lights that'll flash at you, you can set it.
Oh, you click it onto your torque wrench?
Yeah,
Yeah,
well, not on a torque wrench, just onto a wrench.
onto any wrench.
Really?
Yeah, just
Yeah.
on a regular wrench, you can change the socket.
I've seen those,
And it works really nice, because you can set the metric, you can set the English, newtons,
Yeah.
whatever you want.
And it's probably very stable, I would guess.
Yeah.
Yeah.
I actually bought a couple of torque wrenches to do my plugs a long time ago. Because you have to have a torque to X number. But it's one of those where you have a handle that screws,
Yes, right,
and you set it to a certain,
That's the
Wait.
quicker one, yeah.
right.
so if I turn that all the way to 0 and it clicks easy in my hand, that's calibrated?
I don't think so. I think they probably want you to test the range, is probably what they want you to do.
Well, that's what I was asking about. When you said it's calibrated to 0,
Yeah,
it's good enough. I'm like, well, wait a minute.
It's a different
style.
It's a different
Yeah.
style.
Yeah, basically, there's nothing, yours uses a screw
Right.
and a spring and an over-center device in it. All mechanical devices that could, wear or that sort of thing. The nice thing about a beam type is it's steel. That's all there is to it. It's just the deflection of the torque wrench relative to the.
Yeah, an old one I had was essentially, that was about that long, it had a needle that came from the handle all
That's
the way
right.
to.
That's what I'm talking about.
That's the beam.
That's a beam type, yeah. Now, basically, you can't go wrong, other than if you
Well,
knock the pointer or something.
after 20 years of use, there's a certain amount of change in the, well,
Not if you're going back, if you haven't gone past.
So we talked about requisite knowledge, we talked about having a reference document, a manual, or a service bulletin or something. We've talked about the tools. The last thing is you need to make a logbook entry. A lot of people don't do this. And the logbook entry, looks like this. It has to have a description of the work performed. It has to have your name. It has to have the date. It has to have your certificate number, so you need to be a private pilot to do this on a certified airplane, and a signature. And one other thing I recommend doing is also putting, if you're working on the airframe, write down the airframe hours at that point. If you're working on the engine, write down the engine hours at that point. It's not a requirement, which is really weird to me, but it's really handy for reference, right? When did I change these spark plugs, last, that kind of thing. So I just want to go back and talk a little bit about changing a tire on an airplane. So on an airplane, you need to jack the airplane to change the tire, right? And there are specific jacking points on the airplane made to jack the tire. And there are also tools made that you can use to jack the tire, the wheel off the ground, that are special fixtures that you can use to jack it in places that don't have like jacking points. For example, if you've got a Cessna, high wing Cessna, and you've got a flat tire and you want to replace that wheel, that tire, you may not have one of these really tall jacks to jack the wing up. Well, they make a tool that will attach to the spring gear, tap on the spring gear so that you can jack just that one wheel up. So if you're going to try to fix that, you should have the appropriate fixture or equipment to do it. And like we've talked about, there's a lot of subtleties to these airplanes. It's not like a car where you could just pull the wheel off, take it to somebody, put a tire on, and you put it back on. And I'll give you one example. These aircraft wheels are have usually got shims associated with them to shim the wheel along the axle. And the reason they have that is they have a disc. This is typically for disc brakes. They have the rotor is attached to the wheel. And depending on whether you have Cleveland brakes or where's some others? Shin, Matco, something else, those spacers are different because they have to fit inside the caliber in a particular place. And I've had mechanics on my Bonanza not keep track of the 4 shims, which are different thicknesses that go on one side or the other. And this happened to me once. It was actually Stafford. I got in the airplane, I taxied down the runway, and I hadn't checked the brakes. And I'm going down the runway, and I start to slow down, and there's no brakes. Because he put the shims in the wrong order. I've also seen mechanics put them in, and it locks the brake. And now they usually catch that when we take it off the jacks and stuff, but it'll actually lock the brake. So it's not a big deal, but when you disassemble it, I advise you to take a picture of where those shims go. And as you disassemble the parts, disassemble them in an order that you can just follow and put them back together. So there's little nuances like that. Another one is, notice this tire has a red dot here, and this tire has a red dot here. Who knows what that red dot is?
Based on those pictures.
You can see it. It's a balance point because the valve stem slightly gives a different balance. And so that's the mark on the tire that says, we balance this on the spin balancer, and if you put the stem valve here, you should be balanced with the tube in the tire.
Yeah.
Did I get it?
You got it. Yeah, this is the lightest part of the tire, and they want it adjacent to the valve stem because there's some weight associated with the valve stem. And
the lightest part?
yeah, it's the lightest part.
Because the valve stem adds some weight.
Because the valve stem adds some click.
Click, click.
Ooh, look at that light bulb.
Also, these are split wheels. So these wheels are held together with, a lot of times on my aircraft, these 3 bolts, okay? And you know, they have quite a bit of force on them when you put.
It's a lot of fun to take them apart.
30
They
or
shoot
40.
bolts all the way across.
Don't ever take them apart before you air it down. And it's best when you air it down, don't just go with a screwdriver or something. Pull the valve stem so it's all the way down. You know it's all the way down. The tire is quite hard to get off the rim. It can take clamps, you know, putting clamps around the tire to push it in and release it from the rim. Or in my case, a lot of times I'll take two 2x4s, one on each side, and I'll stand on the 2x4s, and you know, I have enough weight to pop it off. Because the 2 rims have a countersink, when you put it back together, one slides slightly inside to the other, and there's a shoulder right there. It is incredibly easy to pinch the tube. These are tube that have tires in them. And what's really a problem with this is you can actually pinch a tube. You can pinch it so bad that you put the air in, it's making all kinds of noise. But you can actually pinch a tube just barely. And it actually won't really show up until the first time you put some load on that tire, like you're braking or something like that, or you set it down off the jacks, and all of a sudden it will start to develop a small leak. So when you want to inflate the tube a certain amount, not too much, but slightly inflate the tube when you put it in. You want to put some foot powder on it. Talc, thank you, Steve. Foot powder smells better, but no.
Depends on foot powder.
Talc carcinogen.
Yeah, it's
They
carcinogen.
actually make talc for just doing.
Just
this.
don't put it inside your body, okay? So you want to put
Surgical test.
it on the outside, so it'll slide and it won't get stuck in that. So those are kind of just some of the nuances on a tire, and airplanes are different than cars. So if you've never changed a tire but you want to change one, great. Just do it with your mechanic helping you or supervising you the first time.
Wondered whether a silicone spray would be appropriate as a lubricant.
No.
I've never seen anybody use that. I would worry it might be gummy or get sticky or something like that.
It doesn't help with rubber.
Yeah, okay.
It does not help with rubber.
There's your answer. Okay. Any other questions about maintenance of the aircraft? All right. Let's talk about. There is one more topic here. I threw this in because I'm so excited about it. This is just tremendous. So, how many of you have heard about Mosaic? Okay, Mosaic is a new rule the FAA is coming out with to expand the light sport aircraft category. And it is a big expansion. It's going to allow things like Cessna 172s to be called light sport aircraft. It's going to allow, in fact, older model 182s, they're 4-place airplanes, will fit into this new category. We'll go into details like that. But, you know, Diamond, American champion decathlons, just a whole variety of traditional aircraft are going to fit into this new category. Some of Taylorcrafts, Cubs, Super Cubs. So it's called Modernization of Special Airworthiness Certificate. So it's going to expand the category. Oh, who cares about expanding light sport? Well, I care because I'm getting older and I can fly light sport with just my driver's license. I don't need a medical anymore to fly light sport. A light sport is commonly, and it's still true of the rule, it's a 2-place aircraft. But now, a light sport can be a 4-place aircraft. As a sport pilot, you can only fly 2 people. But if you have a private pilot certificate or higher, you can fill those 4 seats. And it'll still be, you'll be flying as a private pilot, but you'll have the same requirements as a sport aircraft. The thing that gets it to what we've been talking about is they're gonna allow owner maintenance of the aircraft, including annual inspections. So now you could do an annual inspection on a 172. Now, I'm gonna qualify that here in a second. Let's see.
Should be noted that none of this is law yet, right?
Yes,
It's still
right.
in the,
Thanks,
you're
Jeff.
they're past the comment phase, but not to the rulemaking.
That's right, so they're in that process right now, yeah. I was gonna save that for the end, you know, everybody gets up and then, oh, it's not law yet. So what's allowing them to do this is the current requirement is 45 knot clean stall speed on light sport. They're gonna raise it to the 54, and several organizations have suggested raising it slightly higher than that, so that the Piper four-place aircraft, yeah, like the Warrior and the Archer, yeah, the 180 horse aircraft can fit into it.
Is there a power limitation on it?
There's no power limitations. What they're gonna do is they're gonna, you know, you gotta build it light to get to 54 knots, right? That's stall speed typically. They're gonna raise the maximum speed from 120 knots to 250 knots, which is just phenomenal. I mean, this is what's proposed. And my own personal observation is we're getting our butts kicked by Europe because they're building these really cool little two-place sport aircraft that will do 250 miles an hour, have retractable gear and variable pitch props, and really, you know, and so they say, you know, people say, well, they're doing it, why can't we do it? There will be no maximum weight limit. Right now it's 1,320 pounds. These will have no maximum weight limit. You say, how can they do that? I mean, that's crazy. Well, the stall speed will constrain that, to be really honest, because you're gonna have a huge wing if you start getting real big, but conceivably you could have aircraft up to 3,000 pounds. They're gonna allow retractable gear, in-flight adjustable props, electric hybrid propulsion. That hasn't been allowed in the past, but now in light sport we have an electric or hybrid propulsion. Mark first.
I've had a discussion with Pierre several times. Pierre's a lawyer, and he's dealt with a couple of crashes locally. And to me, the question that always I think about is, what's the wing loading? The reason why is Santa Fe, Espanola, and I'm guessing here, are pretty windy places, pretty turbulent in the afternoons. And Pierre is vehemently against light sports because of the light wing loading, that they're just not safe here. In Chicago, fine. LA, fine. And does the FAA look at that or mention that at all?
I think that is a motivator, to be really honest. You know, Pierre is absolutely right, in my opinion, that light wing loading, you know, you get much of a gusty wind or crosswinds. You know, you're a feather in the wind compared to like flying a heavier airplane with a heavier wing loading, a 182 or you know, Bonanza 172, any of those heavier wing loadings. The other thing is that 1,320 pounds really didn't give people enough margin to build sturdy training aircraft. There were a lot of accidents, and continue to be a lot of accidents with LSAs in training, not just because of the light wing loading and they get blown off the runway. It's because they hit the ground drifting and it breaks the nose gear off or something like that. They're built very light. They meet the minimum requirement, PSTM requirements, but they're built so light that in a training environment where you don't make great landings all the time, that they have a lot of gear problems. They have a lot of accidents, don't result in fatalities or anything like that, but the aircraft is good. Well, you have
So I was just gonna say 1,320 limit, that's on airframe,
that's the total gross weight.
total gross weight.
Yes.
Originally, that's what it was
Okay.
in the current rule, but now they're not gonna have any gross weight. So in theory, you know, you could you could build a 6,000-pound airplane, but to get it to stall at 54, you'd have to have 60-foot wings on it or something like that. They're gonna allow turbine propulsion. They're gonna allow multi-engines on light sport aircraft. They can carry up to 4 people, but only 2 people if you're a sport pilot. They're gonna allow helicopters for sport aircraft. And so this is gonna allow a lot of legacy aircraft that people for a long time have wanted to have fly. Oh, let's see, go this
Wasn't
way.
there a caveat on the multi-engine that the engines had to, however many engines you had, that the rust line had to be the center line of the airplane, so if one failed, it didn't change?
I haven't seen that. It could be in the rule, but I haven't seen
That's
it.
that old special one they did for the Cessna 337s. They had a special rating, which was multi-engine but center line only. But that's an old thing.
Yeah, I don't
think
so, Scott. You could be right. I don't know, because I read through the NPR one time. It's like 300 pages. I mean, it's incredible. It's in there.
I have an echo of reading that somewhere, but
Yeah. But I know one of the reasons they were doing it is that one of these concepts for aircraft are distributed propulsion systems, where you have small motors
Especially with electric.
along the wings.
And
which is
like a lot of rotorcraft based on, quadcopters and such.
Yeah. Okay, so finally I'm to the maintenance stuff. They are saying that the owner, the rule is saying they would like to have the owner pilot be able to maintain the aircraft, do the annual inspections. They actually don't specifically say annual inspections, but they're implying that. But they're saying we probably need to do more they need to be more educated than they are currently for the current LSAs. So right now, for specific LSAs, you can go to a 120-hour training program and get basically your repairman's license, which allows you to maintain the aircraft, repair the aircraft, and do the annual inspection with 100 hours of training, 120 hours of training. People are thinking that, that's what they're going to head for this, but the FAA didn't say that in the rule. What they said was, it will likely require attendance of an aviation mechanic, general airframe, and power plant maintenance course. So, it's not saying getting your A&P, okay? And it's not saying you need 3 years of experience to do that. But what it is saying is you're probably going to end up going to more of a course, in my mind, more of a course than you would for an LSA. So, that's yet to be determined, but it's definitely headed in the right direction. Okay, sorry about that, a little distraction. So I'm going to whip us through borescoping here. Okay, what is borescoping an aircraft? How many of you know have either tried borescope or seen one done? Yeah, okay, maybe a third of you. Okay, it's the visual inspection of the interior of the cylinder. So basically you pull the spark plug out, you take a tool like this, this is a borescope. You plug it into an iPad or a cell phone or a laptop, so you get a picture of it, a video. They have the capability to take pictures or to take video of what you're doing. And if you're looking for a wobbling valve, it's really nice to be able to take a picture of that valve as it moves up and down if it's wobbling, telling you you've got a problem either in the seat or in the valve guide. They're adjustable. You can bend the tip around so that you can stick it down in the cylinder and then look back up at the valves and the spark plug hole in the head. They're real lightweight, they're really easy to use, and the cameras, and they're self-lighted, they have a very bright light in the end, and the cameras themselves have got phenomenal definition nowadays and range of focus. So, 10 years ago, something like this would probably have cost a mechanic $3,000 or $4,000. This one costs the checker $300. You know, it's really cool stuff. You'll see when we do it. The really nice thing is that you can actually look at the things in the cylinders. You can look at the valves. You can look at the cylinder walls. You can look at the piston. You can even see the rings. If you see a lot of the rings, you've got a problem. You just want to see a little bit of the ring. But it's a visual inspection. So why take the time to do this and buy the tool? Well, it's going to reduce your maintenance because you'll catch problems before they become problems. It's going to reduce the cost of maintenance. It's going to prolong the engine and cylinder life. You know, it's really common in the higher performance aircraft to have to do at least a top end once during the engine. And that's usually because of how the cylinders are being operated. Having a multi-probe engine analyzers in the airplane helps. But there are some things you don't see on multi-probe, and being able to borescope and see a developing valve leak, or that suddenly you're getting a strange deposit on the valve stems, those are things you can actually fix before you have a catastrophic failure. So that's, you know, an engine's pretty expensive to overhaul if you have a catastrophic failure in it now. With the borescope, on a regular annual basis, or 100 hours if you're flying a lot, you're going to catch these problems before they become catastrophic. So that, to me, is really great, and it means increased safety. So what do you need to do a borescope? Well, you need the borescope and, at a minimum, a cell phone to be able to look at the pictures and to record them. You need the tools to take the ignition wires off the spark plugs. You typically just do the top spark plugs, the most accessible ones. You'll need a wrench, a spark plug wrench to take the spark plugs out. And you'll need a torque wrench to put them back in, and you'll need spark plug gaskets. It's now recommended when you repull plugs that you replace the gasket in it. Now, if you're an old timer like some of us are, you can anneal those gaskets and replace them that way. But you don't want to just keep torquing the same gasket, because pretty soon the gasket absorbs. To get a good seal on the gasket, it needs to give a little bit. And copper work hardens over time as you torque it. And so if you keep using it, the gasket will get really skinny. When it gets to where it's been squished out so much, it's hard to pull off the threads because it's interfering with the threads. You know, throw it away. But in the meantime, the cheap route is you can dig propane torch and anneal the gaskets if you want. So what's the procedure? Really simple. Okay, remove the top cowl, remove the spark plug leads, remove the top plugs, find top dead center on that particular cylinder, put your thumb over the hole, pull the prop through. This is after you've made. One of the reasons you want to, by the way, you want to do pull all the spark plugs out, is you can pull the prop through and you're not going to get a kick or a fire because there's no compression on any of the cylinders. If you just do one cylinder, you need to be particularly careful of making sure that no fuel got into that cylinder. You know, when you shut it down, you pull it fully. You want to make sure that the mags are properly grounded, and you need to be extra careful because if any fuel got left, then you can have a fire. Bring it up to top dead center, so you pull the prop in. You see us do. You pull the prop through with your thumb on the compression cylinder. And you'll hear it feel it start, and you'll hear it start to compress. And you keep going until it stops pushing air out the hole, and you top dead center. Then you roll it back 180 degrees, the propeller 180 degrees, and get the piston at the bottom of the cylinder. And now you've got a lot of room to stick the borescope in, look at the piston, look at the cylinder walls, get the little end to flip back, and look back up at the cylinder. And then, I'm going to recommend you follow the borescope inspection protocol, which I'm going to talk about. And this is documenting how do you look, what do you look at, how do you look at it, and how do you document it. So, one of the things, and this is what got people really borescoping cylinders, is couple really smart mechanics, Mike Bush included, figured out that you could start to see when a valve was starting to leak. And way before you would find it with a compression test. Way before it was leaking enough air to show up in a compression test. And if you found it early, you could repair the valve in the seat by lapping it in place inside the engine without pulling the whole cylinder off and on, which has a lot of potential downsides. And a technique has been developed so that you can lap this in place and get the lapping compound out without, flush it out without damaging the ring through the cylinder. So what are you looking for? Well, normally, a normal plug,
Just a question, presumably that's not an owner maintenance.
the lapping and flushing part?
Lapping valves.
Yeah, I would not undertake that without a lot of mechanic supervision. Because you are going to put grinding compound in there, basically, right? You don't want to flush that down in the oil. So it involves like draining the oil. It involves filling it with a special flush after you're done to push all the through past the piston rings and all that kind of stuff. And it also involves how you put the lapping compound on and to minimize any coming loose while you're lapping in and that sort of thing. But it can be done, and it's a lot easier than pulling a cylinder. These are burned pizzas. So these are discolorations you don't normally see on an exhaust valve. Normally you'll see either a sort of a blackish carbon composite or a tannish composite on it. But you can see different deposits depending on how the engine's been run and the type of engine. And these are all okay valves. Any of these, even though they're different colors, and even though they have different levels of buildup on them, there's nothing wrong with these valves. They're working just fine. And the way you can tell that is everything is symmetric around the valve. There's no localized hot spots like you're seeing here. Everything is symmetric, even these valves with buildups. So as long as everything's symmetric, the seat is still working on the valve. Because the seat is how you transfer heat out of the valve. If you start to get a portion of the seat that's not sealing properly, it's not going to transfer heat properly, and that portion of the valve is going to get to a different temperature than the other parts of the valve, and that different temperature shows itself by a different color. So here's a valve it's not quite asymmetric. You see this reddish here and a little brown here, but that's not a big deal. Here's a valve where you're starting to see a temperature variation, and likely you're not making good contact on the seat, or as good contact as you should. Here, you're starting to see that there's several places on the seat where that's not making contact. If you catch the valve in any of these places, you can lap it, and that valve can last the life of the cylinder. When you start seeing large variations in temperature, and in particular, a green deposit, green means stop, that indicates that you're headed towards a valve failure. And the reason you're seeing green is you're actually changing the metallurgy of the valve itself. It's just gotten so hard that the metallurgy is changing. And when you see green beginning to show up, there's probably about 100 hours left before that valve catastrophically fails. That's what people are saying. And what's a catastrophic failure? Well, it starts with a crack, like you get right here. You can see there's quite a bit of green on this valve. It starts with a small crack, but then it can lead to something like this. That's a valve head stuck in a piston. And you know that engine's not happy anymore. So Borescope will let you catch this before failure. It'll let you, if you're looking at it early enough, you can catch it and say, oh, I need to get that valve lapped. If it gets to this point, you say, oh, I need to pull the cylinder and have that cylinder overhauled. But if you get it to this point, you're probably looking at an engine overhaul. So a lot of times airplanes will pass the compression test, but they're within 100 hours of failure. The valve's within 100 hours of failure. You can look at things like valve seat recession. That's this one right here. And in this particular case, the valve has, normally the valve head will sit a little above the top of the cylinder. But valve seat recession occurs every time a valve opens and closes. There's a potential for metal transfer from one to the other on those contact points. And under certain circumstances, depending on compression ratio, operating temperature, type of fuel you're using, the amount of lead in the fuel, you can transfer more or less. Historically, leaded fuels have helped prevent that transfer. This particular valve picture came off of the University of South Dakota's, one of their Seminoles. They have about 100, what do they have? Roughly 100 aircraft. They do have a massive flight training program. They fly 100,000 hours a year in their flight training program. This is one of their twins, and this Seminole started losing power and rattling around on one of the engines. And when they pulled it apart, they saw this recession, and you can see this lighter area right there. This is the cylinder out. That's daylight through there. So the valve is recessed so far, and a portion of it, it's about to go out the other side of the thing. And they think this is due to the use of Swift fuels, which is one of the unleaded candidates for replacement of leaded fuels. They think that. That's not actually been completely confirmed, but they stopped using that fuel and went back to leaded fuels when they found this and about 14 other cases of valve recession in the fleet. Sticky valves. You hear about sticky valves. Well, you can see that before it happens. This valve is getting very close to sticking because you see this buildup on here, on the valve. This is the valve stem. We're looking back. This is the valve guide right here. You can see that there's a big buildup all the way to where the valve goes back in. Normally, when you're looking at a valve that's open, you'll see a shiny section of just pure valve stem. You won't see buildup on it because it's going in and out of the valve guide, and it's being protected. When you see this kind of buildup, you're going to stick that valve before too long. But sticking it means it's going to jam either open or closed, and that can be a problem. You can see detonation. So, who knows what detonation is? Anybody? Roger?
It's firing at the wrong time, so it's an explosion instead of a continuous burn or a smooth burn.
Exactly. The most common cause of detonation is the airplane not being timed properly. If you advance the timing too far in airplanes so that they fire too early, normally you want as the piston is coming up on a compression stroke, you want it to fire slightly before it gets to top dead center, and somewhere like 20 to 25 degrees before top dead center. And what that does is it starts the burn that Roger just mentioned. And if you started it right at top dead center, it would, if you lit it there, you could light it there, but then it's just immediately going to put itself out as it goes into or reduce the pressure as it goes into the power stroke. By firing it early, you give it a head start to get going, to get really developed, so when it gets to peak and starts down, you've got the maximum pressure on it to generate the power stroke. To give you some idea, on our aircraft, that peak pressure that you'll see is around 500 psi in a properly running engine. If it starts to detonate, it can be 2,500 psi. It's a huge difference. And it creates heat. It can, the shock waves coming off that can actually dent the piston head, erode the piston head, and melt the piston head. So in this picture, the piston is just starting to melt right there from a detonation. And you can see the ring is really exposed right there. Normally you can't see that much of a ring, but it's melted away enough that you can see the ring in there. And you can see other little signs along the edge here. The other thing that can cause detonation is if the engine gets too hot. A good example is you're taking off at sea level and you lean the mixture immediately after takeoff. You know, we're supposed to wait till we get to 3,000 feet, but you got it at full power and you immediately lean it to peak EGT. That cylinder is going to burn a lot hotter than it would normally because the fuel isn't coming in to cool it. And when that happens, it's the edges of the piston that become real hot spots, and they can cause it to ignite early. And here's another one that is worse detonation. Here you can see the piston land is completely, the ring is completely shown. And even underneath it, above the wrist pin, you can see erosion. So it was melting the aluminum below the ring. Now, in a bad case of detonation, it will lead to something called pre-ignition, where the piston gets so hot and the head gets so hot that even as it starts to come up, before it's even traveled very far at all, it'll ignite the fuel by itself. You don't need an ignition system. It's basically gone into diesel mode. That's what it's gone into. But it's not, our airplane engines aren't built like diesel engines, so they can't stand this detonation. And the really bad thing is you can hear detonation in your car. You can't hear it in an airplane. It's just too noisy. You cannot hear detonation when it's happening in an airplane engine. So that's why it's really good to have engine analyzers. If you get pre-ignition, you're probably going to have an engine failure within a minute or two. It's really bad. Because what it does is it does this. It blows a hole completely through the piston and injects the case with all kinds of metal and bad stuff. And literally you can destroy an engine in a minute or two when you're in that mode. Another thing you can see is cracks. So this is a crack in the cylinder. When you're looking back at the valves, you can also see cracks. Is this interesting, you guys, or am I too boring? Is this okay. I don't want to.
What's nice about flying at this altitude is harder to get the pre-ignition.
It's really nice.
And I took out of here with Brian and Neil with me. And I had just recently timed my electronic mags and made the mistake of normal mags, you set it at 25 degrees before top dead center. Well, I set it at that, but the electronic mags wanted it set at 0 at top dead center, and I didn't do that. We took out of here and the temperatures were going sky high fast. And so the throttle back, lift back around, didn't get any damage in the engine, but and you got to catch it early, you got to pull back to keep your temperatures down. And as far as we know, we didn't get any detonation. We looked at the cylinder and we were fine.
Didn't see.
Oh my gosh,
So that's great to have a borescope to be able to do that, right? You can go down in there, you can see, oh yeah, I don't see any piston erosion or anything like that.
So the electronic ignition requires 0?
yes, because it electronically sets it at 25 degrees top dead center.
Ah, okay.
Mechanical is 0.
Yes, because the detonation physics doesn't change.
So if you use electronic ignition,
It's pre-calibrated.
read the instructions
Yeah, I see.
many times and memorize it.
Another thing you can catch is a stuck piston ring. So here's an example of a stuck piston ring. In this case, it's the oil control ring, which is the most common thing. The bottom ring basically keeps the oil out of the cylinder, but allows enough by so that you can lubricate it. And so the borescope shows, here's a line of oil that's obviously seeped past the piston. And that can be repaired with a flush, solid flush of the piston rings. So there's a procedure to repair that if you've got sticking rings. Cylinder scoring. This is the stuff you see that's kind of cross-hatched. That's the cylinder honing, original honing. And unless it's a chrome cylinder, which we don't really have anymore, They hone all these steel cylinders nowadays. And those hone marks, actually, they're really just tiny scratches. What they do is they hold the oil film. They hold a little bit of oil film in them, and that's what helps lubricate the cylinders. If you see a cylinder that's shiny, you can see the reflection of the probe and everything in it, with no hone marks, that cylinder is worn. And it's time to replace it because it's not going to lubricate properly anymore with no honing marks, no scratches in it to hold the oil. In this case, I'm pointing out something a little bit different. This is being scored. See these big score marks here? That's being scored by, it looks like maybe a piston, a wrist pin on the piston is rubbing against it or something like that. But if you see this, you want to take a look at that. You probably want to pull that cylinder and take a look at it. If it's light scoring, you can hone it again and get rid of it. So it's salvageable. If it goes too far, you're going to have to put a new cylinder on. And you can see cylinder corrosion and overheating. And I've got a better picture of that I'll show you in a minute. So here's the things that you could fix in situ. You can fix exhaust valve leaking, sticky valves, and stuck rings. So you don't even have to pull a cylinder to do those kinds of things. And you're not going to find those in a compression test. This is that cylinder we talked about. This cylinder has had a heck of a life. If you look at it, you can barely see the cross-hatching, right? This is corrosion. So that cylinder sat for a long time in a humid environment, and it started corroding. That's what this is right here. And probably the end result of all that is this tempered look, this rainbow look, tinted portion of the cylinder. That's where it overheated. So once a cylinder overheats like that, usually it means that it's probably partially annealed the rings, so they're losing their springiness. That's a bad sign if you see overheating in the cylinder. So this one poor cylinder had a heck of a life. And you definitely want to replace it. In fact, with that kind of corrosion, you'd be expecting to see other parts of the engine with corrosion issues associated with it. Okay, so I'm not telling people not to do compression tests. Those are still not a bad go, no-go gauge. Those are sort of like, this one didn't work. Those are sort of like getting your blood pressure in the doctor's office, right? It's supposed to be in a certain range. If it's above that, you gotta try to understand why. If it's below that, you probably understand why. But you could still be perfectly healthy. You know, maybe you have white coat syndrome when you go to the doctor's office, right? You get nervous and your blood pressure goes up. Or maybe you just had, 3 cups of coffee. And if it's really low, it's maybe because you're really fit and you're a runner. And so your blood pressure is just naturally lower. So it tells you, you may have a problem, you may not have a problem. You don't know how bad it is. You don't specifically know what it is. But it's not a bad go, no-go kind of check. But a borescope is more like getting an MRI. You can actually see into the engine. You can see what's going on specifically. You can see details. And it's a much better diagnostic to catch problems before they really become bad, while you can still deal with them. And maybe just simply the way the engine's being operated. It could be the way the person is adjusting the mixture, or that's something that can be fixed without even working on the engine. Borescopes are really cheap. It takes about 30 minutes to do a 6-cylinder engine with a borescope once you learn how to use the borescope, so it's not that much more time. And then the last part of this is in the near future, even though you're not an expert in borescope pictures, you're going to have the opportunity to send pictures to experts that can tell you what the issue is. And Mark, you were going to say something.
Doesn't the FAA actually require compression tests?
Yes. That may change in the future.
Yeah.
But right now they do require it. I mean, a lot of people are saying borescopes are in place of compression tests. Why waste your time on compression tests when you can do a you know, Borescoping. Because you can find everything, you know, with Borescoping you can with a compression test. But it hasn't changed yet, so. And a lot of mechanics like compression tests, and they become really experts at compression tests.
Borescope seems safer.
It is safer. That's what I'm finding.
You're not pushing against the compression,
Yeah.
holding the props, yeah.
So I stuck a valve on takeoff out of Espanola a while back, and that's a 4-cylinder engine, you know, we're at 7,500 or 5,500 feet down there, 5,800 feet. And it was shaking like a banshee. I didn't know I'd stuck a valve. I just thought something had let go on the engine, that's how it felt, and it was shaking like a banshee. So I fortunately it was high enough, I could make the impossible turn, come back and land. And it was really funny, by the time I taxied back, it seemed like it had really pretty much stopped. It still wasn't running smoothly, but whatever had happened, it kind of stopped. And long story short, John loaned me his hanger down there. Thank you, John. And I spent a couple days and borescoped it, and there were very large buildups on the stem of the valves. And had I been doing borescopes on that engine prior to that, I would have caught that. I was looking at the valves, but I wasn't looking at the valve stems. I just wasn't smart enough yet to know what all to look for. If I'd been in the Bonanza, that would have been a bad outcome, because I would have ended up outlanding off the runway. I could not have made the turn in the Bonanza. I wasn't even close to it. So I probably would have ended up, I might have been able to limp around on 6 cylinders.
So how do you look at the valve stems? You turn the propeller until one of the valves opens and
I'm about to
is
show
that how
you.
you do it? I'm sorry?
I'm about to show you.
Oh,
I'm
excellent.
about to show you. But first, I want to tell you something really cool that's going to happen here. And this is something Mike Bush with Savvy Aviation is starting. For those of you that don't know Mike is a very experienced, excellent mechanic. He started a business to help people troubleshoot their engines a while back. It's been extremely successful. There's an annual fee to do it. But he has mechanics that can troubleshoot what's going on, can work with wherever you're stuck and the mechanic that's looking at it to try to identify the problem and fix it on site. So you're not sitting there trying to do it if you don't know anything about engines. So he wants to add another thing to that. He wants to set up a database where people can voluntarily send their borescope pictures to him. What he's going to do is, when he gets enough pictures, is he's going to use a neural network to train a computer, essentially develop artificial intelligence to read these borescope pictures. And when you get 1 million pictures of valves, I can't think of any mechanics that's probably seen 1 million pictures of valves. And and it's just like face recognition or something like that. You can teach a computer to catch these things way early. And it's a service he's going to provide. And so if you'd like to participate in the program, there's a certain protocol he wants you to use. And this is the protocol. This is what we did on skips. This is kind of what you're going to see today when you go down there. It wants you to take 11 pictures. This is looking at the piston head. And you can see there's some deposits on here. It wants you to turn around, look back at the face of the exhaust valve. You see that's a more common coloration for an exhaust valve. Then he wants you to move the prop to where you open the exhaust valve as far as you can. And then you can take this little probe and you can turn it like this and you can kind of get it right in there, and you can take a picture like this, looking at the valve seat and looking up at the stem. And if you look here on skips, to be more clear on this picture, on the intake, see it's shiny here. There's no buildup in the valve guide area. So Skip doesn't have to worry about sticking problems. There's a little buildup here, but nothing, like we saw in the other picture.
It's always a nice feeling when Will didn't go running, screaming out of the hangar. That made me feel good.
Skip is so funny. I was trying to teach him this protocol, you know, go through all this stuff, right? And he just wanted to go look at the next cylinder. To heck with making these pictures. I just want to see that next cylinder, make sure it's okay. And they were all okay. So you do the same thing with the intake valve, and then you take a picture of the cylinder every 90 degrees. And so you can see if there's any scoring. You can see the crosshatching. After 800 hours, this looks almost new. Crosshatching in there. So the Skip's got a really healthy engine. So, any other questions before we go down and let you guys play with the equipment?
One question about the Borescope. Is the articulated part of it, is that a fiber optic based system, or is it a?
It's fiber optic as best as I can tell, John. I'm pretty sure that's what it is.
It's the only thing that's gotta work.
Well,
You can
the
take a look.
LCD cameras are small enough, it's just a tiny chip in the nose now.
Well, and there
Okay.
are those.
Okay.
That's probably what this
Okay.
is.
For like $30, I bought a 6 foot long, I was telling you about, it's a 6 foot long, oops, sorry.
I'm here.
It's about a 6 foot long cable, and the end of the cable is the camera.
Yeah, so that's,
And you plug it in USB.
that must be what it is. Yeah, the earlier ones, I have an earlier one, similar to what you're talking about, that's fiber optics, and it's crappy. I mean,
Yeah.
Well, this
it's
one-
almost useless.
This
You
one
just
is
throw it away.
HD. The camera is HD, it's got a ring of,
Right.
the only thing it doesn't have is it doesn't have the mechanism for curling it around.
Right, that's really helpful.
Yeah.
If we're going peering around like in a wing or something, it's really useful.
It can be really useful. Yeah,
Um,
or you drop something.
Is this fuel proof, waterproof? Can you look inside your tanks?
I don't think I would put it in fuel. As far as I know, it's not solvent proof. What they ask you to do is, you know, when you're going down, try not to jam it into the top of the piston head, scratch the lens and that kind of stuff. You can see it's got a fine wire shield on the flexible section, but there's no indication that's sealed.
So if you want to look inside your fuel tank, you drain it first.
Drain it first, yeah. I'm sure you could look at it then,
Is this something I think I would like to do?
yeah. Yeah, so there's a little technique you learn in it. We can show you guys that. So I guess I'll stop there.